Welcome to the USA Time Machine.
In the vastness of space, now and then a visitor from far beyond drifts into our cosmic neighborhood. In mid-2025, astronomers worldwide caught sight of just such a traveler, 3I/Atlas. Its name tells the story, 3I denoting the third confirmed interstellar object, and Atlas the survey that discovered it. As our cameras trained on it, scientists realized they were observing not just a comet, but a messenger from another star system, carrying clues about worlds far beyond our own. On July 1, 2025, the ATLAS, or Asteroid Terrestrial Impact Last Alert System, telescope in Chile, registered a curious object. Follow-up observations revealed it was following a hyperbolic path, meaning it was not bound to the sun like typical comets. In short, it was an interstellar visitor. The initial size estimates varied, but using the Hubble Space Telescope and others, scientists concluded the nucleus may be somewhere between a few hundred meters to a few kilometers in diameter. Early data showed it was moving incredibly fast, more than 60 kilometers per second relative to the sun, confirming it was not a long-period comet from our own system, but a true interstellar wanderer. Why all the excitement? Because objects like this carry material formed around other stars, perhaps billions of years ago, offering our first-hand glimpse at environments unlike our own. Every planet, moon, or asteroid we explore in our system shares our sun's family tree. But 3I/Atlas comes from somewhere else entirely. It's a rogue, a cosmic nomad. In studying it, we may gain insight into how planetary systems form in other corners of the Milky Way. As 3I/Atlas approached, spacecraft and ground-based observatories were primed. On October 3, 2025, it passed within tens of millions of kilometers of Mars, giving the ExoMars Trace Gas Orbiter and the Mars Express a rare opportunity to image it. One of the most striking features, its coma, the cloud of gas and dust surrounding the nucleus, seems unusual. Observations from the James Webb Space Telescope revealed that CO2, carbon dioxide, dominates the outgassing, far more than typical comets in our solar system. Even its tail structure surprised scientists. Instead of a simple anti-sunward tail, there appears to be an anti-tail, or sunward-pointing dust structure, something rarely seen, possibly tied to how the object interacts with solar radiation and the surrounding medium. Let's track the journey. After discovery, 3I/Atlas continued inward toward the sun. Its closest approach to the sun, perihelion, was around late 2025 at around 1.4 astronomical units, or AU, from the sun, just inside Mars's orbit. As it approached the inner solar system, both its brightness and activity increased. Then it passed behind the sun from Earth's view, but the data captured before and after that passage continue to tell the story. Its closest approach to Earth is safe, not a threat, at about 1.8 AU, roughly 270 million kilometers. Afterwards, it will depart our system, never to return. Its trajectory, a one-way ticket, a fleeting encounter, but one packed with scientific value. Because 3I/Atlas is so different in composition and origin, it challenges our assumptions. Its high CO2/H2O ratio suggests ice is formed in environments either colder or more chemically enriched than typical solar system comets. Its anti-tail behavior hints that the architecture of dust and gas release may operate differently in interstellar objects. Its very existence reminds us the galaxy is full of such wanderers, and our ability to detect and study them is just emerging. Future missions, such as the Comet Interceptor, aim to intercept or closely study such objects. In many ways, 3I/Atlas is paving the way. Consider this, a chunk of ice and rock born in another star system, drifting for eons, finally crossing paths with our sun, our Earth. For a brief moment, it shares our sky, offering a messenger from the stars. It invites us to ask, What conditions prevailed around its birth star? What materials did it carry? What story of dust, gas, irradiation, ejection into interstellar space does it hold? And in studying it, we learn not just about one object, but about the broader cosmos, about formation of planetary systems, about matter beyond our neighborhood, about the unseen majority of our galaxy. In the story of the universe, many chapters go unwritten. With 3i/Atlas, we get a rare peek into a chapter that began far away, long ago, and has traversed interstellar space to arrive here. Though it will vanish from view and continue its journey, it leaves behind knowledge, questions for science, and awe for humanity. As we watch it fade into the depths of space, we are reminded the sky holds more than we know. And sometimes the most profound visitors are those that come only once.
For more videos, subscribe the channel.